topic, we will going to discuss about 4.5a Exploratory Data Analysis or EDA. In EDA, data can be organized using a stem and leaf plot. The measure tendency in EDA is a median or second quartile, or we can use symbol Q2. The measure of variation used in EDA is third quartile minus first quartile or interquartile range. In EDA, the data are represented graphically using a box plot. The purpose of exploratory data analysis is to examine data to find out what information can be discovered about the data, such as center and the spread. Now, let's see the 5-number summary. A box plot can be used to graphically represent the dataset. This plot involves 5 specific values. So, as a conclusion, in your box plot must contain this 5-number summary. These values are called a 5-number summary of the dataset. So first, you must have the lowest value of the dataset or data minimum. And second, you must have in your box plot is first quartile or Q1. And the third value is second quartile or median. The fourth value is third quartile or Q3. And the last value is the highest value of the data set. Note that quartiles divide the distribution into 4 equal groups denoted by first quartile, second quartile or median, and third quartile. Before going further, let's try some example in calculating first quartile, second quartile or median and third quartile. Step 1. Arrange the data in order from lowest to the highest. 9 is the lowest data and 25 is the highest. Then step 2. Find the median or second quartile. If you still remember in previous lecture, to find median value, you need to find the observation with the formula n plus 1 over 2. So, the median is in 5.5 observation. That means it is in between 5th and 6th data. Then, the median is equals to 18.5. Next, step 3, find first quartile and third quartile. So, the first quartile is 15 because it is the median of the data below 18.5. And the third quartile is equals to 22 because it is the median of the data upper 18.5. Next example. So by using the same step, arrange the data in ascending order, then find the median. So the observation of median is on 5th data. That means median is 7. And step 3, the first quartile is equals to 2.5. That means it is the median of the data below 7. And the last one is third quartile. So the third quartile is equals to 9. Third quartile is the median of the data upper 7. Now, let's discuss about subtopic 4.5b, To construct and interpret box plot for ungrouped data. A box plot is based on the 5-number summary and can be used to provide a graphical display of the center and variation of a data set. To construct a box plot, you must follow this step. So step 1, determine the 5-number summary. And step 2, calculate the values of upper and lower inner fence to determine whether the data has outlier. So upper inner fence is equals to third quartile plus 1.5 times third quartile minus first quartile, or this one is interquartile range. For the lower inner fence, it is equals to first quartile minus 1.5 times interquartile range. And outlier is an extremely high or low data value when compared with the rest of the data values. Step 3. Draw a horizontal axis with a suitable scale and locate the number obtained in step 1 can be located. Above this axis, mark all the 5-number summary with vertical lines. And last step, connect the quartiles to each other to make a box, and then connect the box to the minimum and maximum with line. Here is the example of a box plot. The box plot must have 5-number summary, which are minimum data, maximum data, first quartile, second quartile or median, and third quartile. Use the lower inner fence and upper inner fence to check whether the data has an outlier or not. The data lies within the upper and lower inner fence. As a result, the data has no outlier. Look at the second box plot. The observation that lies outside fence is known as outlier. So we have to take the nearest value maximum that inside the fence and mark the outlier with the dense circle or cross. Actually, the shape of data distribution can be also determined from a box plot. There are 3 shapes of the distribution. So first distribution is symmetrical. If you can see from the diagram, the tails are the same length and the median or second quartile is in the center of the box. Second, positively skewed distribution. If you can see from the diagram, the left tail is shorter than the right tail and the median or Q2 is nearer to the first quartile or Q1. And the third one is negatively skewed distribution. The left tail is longer than the right tail and the median or second quartile is nearer to the third quartile. Example, given the data set, find the first, second, third quartile, upper and lower inner fence. Then construct a box plot for the above data. So now let's discuss the solution of the example. Before you answer the question A, you need to arrange the data in ascending order from lowest to highest. Then find the 5-number summary. So first, the lowest data is 1 and the highest data is 17. Next, find the median or second quartile. By using the formula n plus 1 over 2, the median is on 7 observation. Therefore, the median is 6. Next, find quartile 1 and quartile 3. So quartile 1 is 2.5. Remember, quartile 1 is the median of the data below 6. Okay, for the third quartile or quartile 3 is the median of the data upper 6, which is quartile 3 is equals to 8. Then find the upper and lower inner fence. By using the formula, lower inner fence is equals to 2.5 minus 1.5 times interquartile range, which is 8 minus 2.5, and it is equals to negative 5.75. So for the upper inner fence, it is equals to 8 plus 1.5 times 8 minus 2.5 equals to 16.25. Question B. Construct a box plot. To construct a box plot, we need to find the 5-number summary and detect the upper and lower inner fence. All the value as defined in question A. So first, draw a horizontal axis with suitable scale and locate the 5-number summary. Now we have minimum data is 1, 2.5 is first quartile, 6 is second quartile or median, 8 is third quartile, and maximum data is 17. Then connect the quartiles to each other to make a box. Then connect the box to minimum and maximum with line. Since the data 16 is an outlier, take the nearest maximum data, which is 9, inside the fan and mark the outlier with then circle. Next example. Given data, find the outliers and construct a box plot. Hence, find the skewness for the data. Here is the solution of the example. In order to find the outliers and construct a box plot, first you have to arrange the data in ascending order from lowest to highest. Then find the 5-number summary. So first, the lowest data is 10 and highest data is 30. Next, find the median or second quartile. From the formula n plus 1 over 2, the median is on 7 and 8 observation. Therefore, the median or second quartile is 14. Then, find quartile 1 or first quartile and third quartile. So, from the data, first quartile is the median of the data below 14. Therefore, first quartile is 12. And third quartile is the median of the data upper 14. So, the third quartile is 18. Then, find the upper and lower inner fence by using the formula. Lower inner fence is equals to 3 and upper inner fence equals to 27. Therefore, the data has an outlier. Since the upward interference is 27, data 30 is an outlier. Then construct a box plot. So first draw a horizontal axis with a suitable scale and locate the 5-number summary. So here is the 5-number summary, which are minimum data, first quartile, second quartile or median, third quartile, and the maximum data. Then connect the quartiles to each other to make a box, and then connect the box to minimum and maximum data with line. Since the data 30 is an outlier, take the nearest maximum data, which are 22 inside the fence, and mark the outlier with dense circle. So make sure in a box plot must contain 5-number summary. Next, determine the skewness of the data. So from the box plot, we can see that the median is nearer to first quartile. Therefore, it has positive skewness or skewed to the right.